Titration of a salt of a weak acid and a strong base. Titration of a salt of a weak acid and a strong base. A strong base with a strong acid. Basically, in these types of titration, we are taking a salt and the salt is containing weak acid and a strong base. So, example of this type, first we are taking the example of this types of salt. For example, we are taking the salt of sodium carbonate, Na2CO3. This salt is the strong base. This salt is contain strong base and weak acid. Now, how we can decide that this salt contain strong base and weak acid? So, by the hydrolysis process, we can decide that this is the strong base and weak acid containing salt. And sodium carbonate reacts with water. Then, after the reaction, it gives sodium hydroxide plus H2CO3. Here is the sodium hydroxide. This one is the strong base and H2CO3. This one is the weak acid. So we can say that this salt contains strong base and weak acid. Now in this titration we are using this type of salt, and with this salt we are using a strong acid. Strong acid like HCl. This is the strong acid. Now in this types of titration the possible reaction becomes. Now in this types of titration, when we are taking a salt like Na2CO3, and with this salt we are taking a strong acid like HCl. Then basically this reaction completed in two steps, since in this reaction this salt contains 2 times of sodium plus, and in the HCl we are containing only 1 H plus. So in the stage first the reaction becomes, that is sodium bicarbonate plus NaCl. That is the first stage. And in this first stage, the equivalence point means a point at which reaction is just complete, is nearly about when pH comes at 8.3. So in this stage first reaction, pH 8.3, that is the equivalence point. Now in the stage first, the neutralization reaction is not complete. So in the stage second, sodium bicarbonate that is formed in the first stage again react with HCl, and in the second stage it gives NaCl plus H2CO3. Yes, it's a second stage. The second stage completed, or the equivalence point for the second stage at about pH becomes near about 4. So equivalence point is this. Now we are seeing in these two reactions that in reaction first the one product is NaCl, that becomes neutral, since when we are when hydrolysis reaction of NaCl, it gives NaOH, that is the strong base, and HCl, that is the strong acid. So its overall solution becomes neutral. But in sodium bicarbonate is having after hydrolysis it's having NaOH. So obviously when we are complete the stage first, then the product having basic medium. That's why its equivalence point comes in the basic range. And we all know that basic range start from greater than pH 7. So in the stage first, the equivalence point near about 8.3. That is follow the range of basic medium. But in the second stage, the product becomes NaCl. That aqueous solution becomes neutral, and the second product is H2CO3. That's a weak acid. So they are having acidic medium. That's why in the second stage, the equivalence point follow the pH in the acidic range, and the acidic range becomes pH equals to 4. So now we are deciding that which types of indicators used for complete this titration. Now pH range for phenolphthalein HPH, that is the phenolphthalein indicator, and the pH range for this indicator it becomes 8 to 10. So phenolphthalein indicator used only in the stage first. We can't use phenolphthalein indicator in the second stage since its pH range is not according to stage second. So for the stage first, we are using the indicator HPH, but the stage second, we can't use the phenolphthalein. Now, for the complete reaction, we are using another indicator, that is methyl orange, MEOH. It's a methyl orange, and equivalence point or pH range for the methyl orange, it becomes 3.1 to 4.4. So for the second stage, we are using the indicator methyl orange, and due to lower pH range, methyl orange can be used stage first as well as in stage second. So if we are want that this titration perform only held by the one indicator, then we are using only methyl orange. So by the help of methyl orange, we can find out the complete neutralization reaction. But if we are using the phenolphthalein as an indicator, then we are find out equivalence point up to half neutralization. It means only first stage. By the using of phenolphthalein indicator, we cannot find out the complete neutralization reaction, since we are saying that in stage second there is no color change appear when we are using the phenolphthalein indicator. So when we are using phenolphthalein indicator, then for the complete neutralization reaction, we are using two indicators. In the stage first, we are using phenolphthalein indicator, and in the stage second, we are using methyl orange indicator. Now we have discussed that's what happens when we are using phenolphthalein indicator and methyl orange indicator. So we are discussed one by one. For example, uh, here one is the base, and the next column is phenolphthalein, that is HPH, and the third one is methyl orange, that is MEOH. So methyl orange phenolphthalein. Now first we are using base, strong base, that is sodium hydroxide, NaOH. If we are using sodium hydroxide, and with this we are using the strong acid HCl and using the phenolphthalein indicator. So the reaction becomes NaOH, it reacts with HCl. Then after the reaction, it gives NaCl plus H2O. Here is the we can use phenolphthalein indicator. Then since equivalence point comes near the phenolphthalein range, so the complete neutralization reaction performed by the help of only the phenolphthalein indicator, and it means here is the complete neutralization. Now the second is methyl orange. If in this titration we are used methyl orange indicator, then in methyl orange reaction is same type, NaOH plus HCl. After the reaction it gives NaCl plus H2O. Here again complete neutralization. Now in the second base we are using sodium carbonate, that is Na2CO3. If in the titration between sodium carbonate and HCl, then the expected reaction becomes by the using of phenolphthalein indicator. Sodium bicarbonate plus NaCl. So by the using of phenolphthalein indicator, we can perform only half neutralization reaction. But if we are using methyl orange indicator, then the reaction becomes 2HCl. After the reaction, we get 2NaCl plus carbonic acid, which is further decomposed and gives CO2 plus H2O. So if we are using methyl orange indicator, then we are seeing that here is the complete neutralization. And the third phase, we are taking sodium bicarbonate, and we are using phenolphthalein indicator, and it shows no reaction. In methyl orange, sodium bicarbonate react with HCl. After the reaction, it gives NaCl plus H2O plus CO2. Now let me discuss another types of titration. For example, if we are using a mixture of two salts, that is Na2CO3 plus sodium bicarbonate, this mixture of two salts, and with this using strong acid HCl. Now we are discussing that what happens when we are using phenolphthalein and when we are using methyl orange indicator. So first, that one is the mixture. In the second is HPH, HPH in beginning, and methyl orange in the beginning. Now HPH beginning and methyl orange after first endpoint. Here is the volume of HCl. Volume of now first we are taking the mixture of sodium hydroxide plus Na2CO3. Let me assume the volume of sodium hydroxide is Z and the sodium carbonate is X, and if we are using the phenolphthalein indicator in the beginning, so the volume is NaOH is completely react with HCl, so it's becoming Z, but sodium carbonate is half react with HCl, so in that case volume of HCl used up is X by 2. Since if we are using the phenolphthalein indicator, then here is only half neutralization reaction. It means Z is completely neutralized by the HCl, but sodium carbonate is half neutralized by the HCl in presence of phenolphthalein. So here is the half volume of the HCl are used, that is X by 2. Now if we are using methyl orange is the very beginning. So methyl orange, in case of methyl orange indicator, HCl is completely react with NaOH and that volume becomes Z plus. Phenolphthalein completely react with sodium carbonate. So its volume becomes, now if we are getting first endpoint, when we are using the phenolphthalein indicator, then HPH is the same, that is Z plus X by 2. But in that case of methyl orange used up, means there is no change in the volume of HCl when we are using of phenolphthalein in the very beginning. But when we are using the methyl orange, then after first endpoint X by 2, volume is more consumed for the complete neutralization of remaining 50% Na2CO3. For remaining 50% Na2CO3. But in that case, there is no use of phenolphthalein since phenolphthalein is not react with sodium bicarbonate. So here is the no change in the volume after first endpoint. So same, this one is. But in case of methyl orange, here is the, we are using methyl orange after achieving first endpoint. Then X by 2 used for the remaining 50% Na2CO3. Now, if they are using in the second point sodium hydroxide with sodium bicarbonate, So NaOH is completely neutralized by the phenolphthalein, that is Z, and sodium bicarbonate also neutralized. And sodium bicarbonate does not react with sodium bicarbonate does not react with phenolphthalein. So here is the volume is 0. But in case of uh, methyl orange, Z for the NaOH and sodium bicarbonate is also bi. Now if we are use this time, then Z plus 0. Now here is the only used by for remaining 100%. In that case, uh, sodium bicarbonate remaining 100%. For remaining 100% sodium bicarbonate, we are taking sodium carbonate plus sodium bicarbonate. Then sodium bicarbonate, it is half neutralized, that is X by 2, and sodium bicarbonate, that is does not react with nothing, that becomes 0. Now methyl orange is completely react with sodium carbonate, that is X, and also completely react with sodium bicarbonate, that is Y. Now HPH, again sodium carbonate, that is half, means X by 2, and no reaction with the bicarbonate, that becomes 0. Now in case of methyl orange, X by 2, this X by 2 required for the half neutralization of sodium carbonate plus by and by, so overall volume means X by 2 for remaining 50% of Na2CO3 and by for 100% sodium bicarbonate. By the help of these types of table, we can find out that how we can find out the endpoint when we are using phenolphthalein indicator or methyl orange indicator.